It's Ian Welfeld, and I'm here to explain my lane detection algorithm code. So, similar to the way we did it in class, first I have a function where I snip the image to get the square, I guess, of the image that I want to deal with. And then I can take a mask so that I could only see the lanes that are relevant, so we don't get confused. Also have a thresholding function, which kind of does two things. One, it creates an image that was grayscaled binary, so it turns like the RGB, the three values, into one value, and then if that value is above a certain level of 100, it'll convert it into completely white, and if not, completely black. And that way we get a black and white image, theoretically, just of the lane lines. We also have the HSV hue saturation value, find like a range that we want to find the lane lines in, so that we can plot it more clearly and allow our edge detection algorithm to work properly and distinguish between different colors. Then we blur. We have a blurring function to get rid of noise. We have the canny edge function, which takes the SHV values and kind of detects the edges that we need. And then from there, we're able to take the Huff lines. In fact, a vote of 40 seemed to work fine, where you have enough points that create like lines with similar slope to kind of detect lines. You convert the points to lines, and then the lines, when they cross each other, create the points. And we find the lines that are relevant, and then we kind of plot them here with the Huff lines, with their values and everything. And then into our main function, we open the video. We check if the video is open or not, and if not, it'll give us a little error. We then go through each of the functions. We snip, we mask, we take the HSV threshold situation, we blur it, and then take edges, and then from there get the lines. And what it does with the Huff functions create like a bunch of lines. There are going to be a bunch of potential lines found from the points that we have, so we need to kind of first of all figure out which ones are the left lines, which ones are the right lines. And in order to do that, we can simply check the theta and see if it's like greater or less than 90 degrees, and that can tell us whether or not it's the left or the right line. And then from there, we were able to kind of loop through all of the lines found for that frame, for the left and the right, because now they're all stored in separate arrays, and we can average them and find one singular line for the right and one for the left for that frame. And we also are storing it in the previous left line and previous right line holders, because when sometimes the lines are choppy, the lines were disappearing, so it didn't detect any lines, and we want to plot, or at least show in the image, the line that was last shown. So that's what this is doing. We're basically copying the snipped image from all the way back up, and we're plotting these previous lines on it when there is no line found. And that is about it. Press Q to quit, and I'll run the code for the first video. Here you can see the edged image here, just black and white. This is it kind of blurred. This is thresholded, mask, snip. I didn't show the HSV in this one, but you can see that the lane detection works pretty well. Okay, and now as for the second video, took a second to line up, and then when it lines up, the edges look very clean for the lane lines. Makes it very easy there's the HSV. Makes it very easy for the computer to figure out where the lines are, and it runs very smoothly. in order to improve the algorithm, it would be nice if I didn't have to change HSV values for separate videos and change the frame for each video. If I could find a way to kind of detect automatically the proper HSV value and snip or mask for each image, so you don't have to manually change them each time, that would be very cool. But yeah, I guess that's for next time.